Good morning or good afternoon. First of all, thank you for joining us for the broadcast. First of all, if anyone can't hear me or if there's any issues, feel free to type it up on the chat. We'll keep an eye on that throughout the broadcast. What I'm going to do is I'll introduce our presenters today. So our presenters are Pierre-Luc Burrill and Dedri Elie. They're both in Montreal right now. So Pierre and Dedri, thank you for joining us and for doing this presentation. Pierre-Luc is the Vice President and Principal of Pajot Morel, a consulting engineering firm specialized in the fields of mechanical and electrical engineering, energy efficiency, and eco-design. Throughout his career, he has made significant contributions to many institutional, healthcare facility, and research center projects, including laboratories. Pierre-Luc holds a bachelor's degree in mechanical engineering and a graduate diploma in management. Over the years, he has obtained several accreditations: LEED AP in 2007, ASHRAE Healthcare Facilities Design Professional, and in 2018, NFPA Certified Fire Protection Specialist. Pierre-Luc is the founding chair of the Montreal chapter of Sustainable Labs Canada. He is also involved in Construction Specifications Canada and gives a certificate course at Polytechnique Montreal. Dedri graduated from Carleton University in 1996 with a Bachelor of Architecture and obtained a Master's in Applied Sciences. From the University of Montreal in 2001, she joined NFOAE in 2010. Dedri has experience in a variety of project types, including healthcare and institutional buildings, and is particularly focused on sustainable design. Her recent experience includes management of the design team for the Clinical Laboratories and Pathology Department at the New Glen campus of the McGill University Health Center, Scientific Equipment Integration Coordinator for the Complex Sciences site Outmont University of Montreal, Project Coordinator for the Canadian High Arctic Research Station, and is currently the Sustainable Design Specialist for the Parks Canada National Collection Facility. So at this time, I'm going to turn it over to Pierre-Luc and Dedri to start the presentation.
Thank you very much. Good morning, everybody, or good afternoon, everybody, as the clock ticks over. So we're just here to share with you our experience on a project that we did for the Green Chemistry Research Chair at McGill University. It's a project that was recently completed, and we just wanted to sort of highlight some of the challenges, but also some of the opportunities that we had on the project. What was interesting is that we were looking at two things: both the advent of green chemistry as a more sustainable, more environmentally responsible way of doing chemistry, which we all recognize as being having its own challenges, as well as the approaches of renovating labs in older buildings. The impetus for the project was the establishment of a Canada Research Chair in Green Chemistry at McGill University. For those who are not aware, green chemistry is an area of chemistry which is focused on designing products and processes that minimize or eliminate entirely the use and generation of hazardous substances. So that was an opportunity to sort of look at the sustainability aspect of the actual usage. In addition, the scope of the project was to actually renovate the labs, renovate existing laboratory spaces to support the research chair. So we looked at it as an opportunity to approach a renovation project differently for McGill, being able to also implicate the work of the McGill Office of Sustainability on campus and further the campus-wide sustainability goals with using this project as a bit of a test case. In looking at the context of the project, there were specific challenges related both at the site level and within the building itself. The project is located on McGill campus in the heart of downtown Montreal, and it's really on the corner, and it encompasses two buildings, Automass and the Pulp and Paper. The Automass building housed the chemistry department, and they're connected. The two buildings are connected one to the other using a tunnel. The space that was designated for green chemistry, the lab space, actually straddles two buildings. So there was that additional complexity in terms of managing and how we were going to approach the project. So this gives you an overview of what we were looking at. So we had, on the one hand, the automass chemistry building. It's actually not a single block. It's 4 separate towers. It was built between 64 and 66 and named after a prominent chemistry chair at McGill University. And then we had the pulp and paper building, which was built in 1927. And that houses what was formerly the Pulp and Paper Research Center, including an annex known as the Mills. So this gives you a sense of, from a volumetric standpoint, what we were looking at, the relative size and shape of the buildings. And ultimately what the issue was is that the site itself was in a valley. And so from the purposes of managing air intake and exhaust, and also the view around, it posed particular challenges in terms of how we were going to make a reasonable intervention and also ensure that the labs were interesting livable spaces. It should be said that the space that was designated for the labs is actually, was actually on the basement level. And so in addition to the exhaust and intake issue that we were trying to deal with, we were also looking at ways of incorporating interesting daylight and view opportunities from a basement level, so it didn't feel as oppressive down there. The space that was allotted was the last remaining space in the building that had not been upgraded or renovated through the years. So the existing labs were in extremely poor condition. And there were more than a few deferred maintenance issues that we had to deal with. So this just gives you a quick sense of what the situation was prior to construction. So you can see that we're looking at, in the center, the Mills Annex. And then you have the Pulp and Paper building to the right. And so it really was, you can see a little bit about some of the existing equipment and where some of the chimneys were located and how we were going to manage all that. Prior to construction, this is just a general overview of what we were looking at. This is in the pulp and paper, in the Mills area, where we have one lab that had some interesting fenestration, but by and large, we were in a basement. So looking at the project itself, there were basically 3 areas of intervention. In the mill, we were looking at incorporating new mechanical space on the roof. We basically did a full upgrade on the exterior envelope, and it was a major renovation to the existing lab. In the pulp and paper building, we incorporated new exhausts on the roof. There was new mechanical equipment in the existing penthouse, and new vertical distribution of the mechanical services throughout the building, and focusing specifically on where the project started, the renovation of existing labs. And then finally, on automass, it was a wholesale demolition of existing labs on the level 0 space to replace those with new labs, and then there was the creation of new exhaust on the roof. So in plan, just to get a sort of an orientation of where we were, this is all level 0, and so to the left, you have automass. We were basically having interventions on roughly 40% of the floor area, and then over on the mill and the pulp and paper and the mill side, we were doing a fairly significant renovation over most of the floor area. It should be said that the areas that the challenge of this project was that the existing labs or the adjacent labs needed to be in continuous operation. So we were managing a construction site and continuous operation of wet labs throughout. More specifically, on the automass side of things, The segregation in this area was a little bit more straightforward in that the building zone versus the zone of intervention were more distinct. And so we did not have as many issues in terms of separating the ongoing use of the building with the renovation work. On the pulp and paper and the mill side, it was much more complicated because we were touching a more significant portion of the work, and we were also intervening in areas where we were having to manage building access. And so things like dust control, things like proper ventilation, proper pressurization, building services, general working, continuing with sensitive lab work directly next to a construction zone were all problematic. There were some key project goals. We were looking for LEED silver level certification. They were also looking to maximize energy efficiency, make sure that there was a good amount of adaptability and flexibility for the laboratory spaces. Because the lab spaces were located in the basement, ways in which we could increase the availability of natural light. From a user standpoint, excuse me, they were looking to make sure that the spaces would support interaction, especially that was a key goal of the research chair, promoting interior views, and there had been a hope that we would have access to vegetation green space, which was sort of the blue sky thinking at the beginning of the project. The challenge, because of how broken up the spaces were and where the labs were located, was establishing an appropriate LEED project boundary because we were operating in multiple zones. And so ultimately, or the initial strategy was to sort of delineate those zones. And in terms of the mechanical electrical systems, for the purposes of how we would approach LEED, we were simply thinking of doing a proration of the overall mechanical spaces versus the overall space. The challenge was that while we decided to pursue LEED certification as a commercial interior, the way in which the mechanical systems were set up on campus, we had district systems that we were dealing with, and so ultimately, in consultation with the Green Building Council, we set it on a strategy of basically looking at only incorporating the terminal units as part of the LEED certification process. The other challenge that happened along the way is that from the client perspective, this started off as labs, renovation, requiring additional services in support of those labs, but it was also seen as an opportunity to improve and to upgrade the mechanical systems throughout the building. And Pierre-Luc will get into that a little bit further later on. But ultimately, it was a bit of a domino effect in that the labs required an upgrade of certain systems, and that just led bit by bit to the overall upgrade of the systems throughout the building, which had not actually been touched throughout the many years of ongoing renovations in the building. So, as I mentioned, there was a number of deferred items. And so ultimately, you can see the extent of what was touched for the sake of simply providing the green chemistry lab space. So what is outlined in green is essentially what we have incorporated or what we zoned as considered as part of the green chemistry lab project that would be subject to the LEED certification. And then what is happening in red is primarily the zones that are concerned are primarily related to the building upgrades. And so we have a combination of an overlapping project objective. So moving to looking at design strategies, natural light was our first consideration from the architectural perspective, and working with the challenge of being on the lower level, also working with the challenge of being in the valley amongst other buildings, we integrated and incorporated a skylight feature to improve the quality of the lab spaces And so with that skylight, we were able to, and the skylight is located in the link between pulp and paper and mills, we were able to provide natural daylight to 85% of the lab area within the pulp and paper mills building. We considered a similar strategy for the auto mass sector, and so this gives you a sense of what we were able to achieve. We did consider a similar strategy in the auto mass sector, however, for reasons of technical and budgetary constraints, we were not able to implement it. The other issue that we had to spend a lot of time trying to assess and determine how best we would approach it was looking at how we were going to manage the fresh air intake and the exhaust at the higher level. So I think I will turn it over to Pierre-Luc at this point.
Oh, thank you, Deirdre. So in terms of electromechanical, the first thing to consider, as Deirdre mentioned, is that we needed to keep all the existing labs and offices and classroom in the pulp and paper building operational during all of the work. This was really important for us. And as an analogy, it's like asking you to replace the motor of a car going full speed on the highway, and I would add on this project to replace the suspension, transmission, and even the tires. So it's quite a challenge. So when we first look at the system available, I would say that they were quite obsolete, as you can see on the picture. In fact, they were really past due their life expectancy, and there was not much that could be salvaged from these systems. Second thing, knowing that we wanted to keep the rest of the lab operational during the work, we looked at how much space is available around the existing system to try to install new elements and do a transition between the old and the new system, but it was really, really limited to some pathway in the mechanical room, and it was really, really dense, so it was not possible again to duplicate system and do a smooth transition. Again, system were really, in terms of mechanical and electrical system, they really were interconnected at various levels, so touching one system, stopping one system had really big impact on a lot of space in the building, so that was quite a challenge. To have a more better understanding of how the building is organized in terms of ventilation, here's a view of the building. In terms of space that were kept operational, you have on the lower part in the basement, you have a portion of it that was kept already renovated that was need to be kept. The first floor was dedicated to offices and classroom. Second and third floor were dedicated to wet chemistry, I would say intense research lab, and also a lab that hosts some really high-end equipment like laser and optical equipment. So the main ventilation strategy at the time was to have a central system on top in the penthouse, in the existing penthouse, which is a multi-zone system supplying most of the building, and having a secondary system supplying a portion of the basement, which was in fact the portion that we wanted to renovate. The exhaust is a bit more complicated. It's done by various exhaust fans located throughout the penthouse with no heat recovery. And these exhaust and supply goes through shafts all around the building. Here's a view of the existing penthouse configuration, which at first seems quite generous, the size, but you need to understand that all the perimeter portion is not usable at all. It's like 1 or 2 feet high space, which is only used for pipes or small ducts. And another portion would be is sloped. So again, it's not that useful to install big system. And the central portion where you see that there's a lot of stuff there, it's really the only portion in the penthouse that's really usable in terms of ventilation, I would say. Just to point something to you, the ventilation system, main ventilation system is in the center of the penthouse. It's a multi-zone supplying all the shafts all around the building, and the exhaust is located all around. So some are there, and So you see it's quite of a micmac of system in the penthouse. The basement here that you can see, you have the central mechanical room, which is in the middle of the floor. You have the ventilation unit, which is stuck between, I would say, 3.5 walls. So there's not much possible expansion there. You have the electrical room feeding the normal and emergency power in there. All of these labs were already renovated. The rest would need to be renovated. And this is the NMR zone that we will talk a bit more about later on. So, and there's also a mechanical room there, which hosts the vacuum system and a purified water system that was installed a couple of years prior to the project, feeding all the labs of the complex. In terms of services, the red dot shows you the services coming from around the building. So the red dot on the lower portion is the water entrance from the city, supplying the domestic and lab water for the building, and also the sprinkler. And there's also the gas entrance there. On the left portion, you have mainly the chilled water for the building. On the upper portion, you have a bit more elements. You have the steam and the condensate return water for the heating of the building. You have the compressed air to use in the lab, and you also have the electrical going to the electrical room. And these comes from other building around the pulp and paper. So our initial strategy, knowing that there was not enough room that we couldn't reuse system and that there was not enough room to install something beside the existing system, we wanted to add a new penthouse, as you've seen on the picture before. So the idea was to build over the mill portion, either by installing equipment on top or inside, and having the exhaust on top of the higher portion, and try to resupply the building by the new penthouse. At the conceptual phase, we elaborate a bit. We realized that it was not possible to keep the mills and reinforce it sufficiently to have a new mechanical penthouse. So we decided to demolish and reconstruct all of the mill, giving us the opportunity to build a better mechanical room and having also better lab at the same time. So the strategy was to have the main ventilation unit with the air intake located on the interior, main supply unit supplying the basement, being able to go to the penthouse and reconnecting all the ducts for all the other labs and offices of the building, and having the exhaust fan located on the roof, opening up the penthouse a bit so these exhaust fan wouldn't be too high compared to the existing element, which was an important element with the regulation from the city, not to get higher than the existing element on the roof. So going to the final design, on the left you have the new penthouse with the 2 new ventilation units. So it's 60,000 cubic feet per minute of air, of fresh air, supplying the basement. And you have the exhaust on top with the heat recovery system also. The phasing was quite important in this project to keep the existing lab operational. As you've seen, the supply was there before with all of the exhaust. So by starting to construct the mill portion and the new mechanical room, we're able to install the supply of all the building, reconnecting the basement first, and then floor by floor, reconnecting one floor at a time with the existing shaft, but with new ducts coming from downstairs instead of up. So during a weekend, there was a shutdown. We would install the duct, cap it up, connect the floor, and then the floor would be fed by the new system. A couple of weeks later, we do the same on the second floor and then the third floor, giving us enough room to start to work then in the mechanical penthouse on top. Here's a view of the new penthouse in the mills. You have the ventilation system and which are the bigger components. All the pump, heat exchanger, heat recovery device to supply the system, and also the hot water for labs and domestic production. Here's a view of the room. underneath the mechanical room, you have also the new electrical room for the building, which was also needed to be redone by adding more space, because we were not able to work in the existing one and keep the existing feeds to every lab in the building. And there was not enough capacity also to supply all the new systems. Here's a view of the existing penthouse on top of the pulp and paper. So that's the final layout in terms of ventilation. So as you've seen, the existing supply system was there. So by reconnecting everything on the new system, we were able to do just enough space to demolish the penthouse there and install the exhaust fan. Then we were able, as another phase, to reconnect temporarily all of the exhaust from the shaft to the fan with no heat recovery. That permit us to demolish the existing fan and clear all of the rest of the mechanical room. So we're able to install the heat recovery unit and then reconnecting finally the system as they should be. You can see a view of the building showing you the proportion of the system compared to the space, with the slope also, and the slope are also there on both sides. So it's quite tight there, but I think it's better than it was. So here's the view of the final installation, I would say, with the exhaust fan. And also what I told you was that we demolished the penthouse in a portion. So this was became an exterior portion with a roof instead of having the penthouse going with a slope there. So that permitted us to install the fan a lot lower than if we install it on top of the penthouse.
Right, and so as Pierre-Luc explained, the original intent had been simply to install the mechanical systems or the new mechanical systems as required above the mill annex. And so at the start of the project, we set about a strategy of reinforcing the existing structure. And that initial decision was taken because we had the NMR, and the NMR had to, in an initial run, they wanted the NMR to remain operational during construction. However, that was taken off the table fairly quickly. And then subsequently, it was a question of being able to protect the equipment adequately. So the intervention on the mills was meant to be sort of an incremental intervention. Upon further investigation and looking at the initial drawings and the conditions, as well as the current building code requirements, it was rapidly determined that that was not feasible and that we would have to do a wholesale demolition and reconstruction of that annex in order to be able to provide the adequate space for the mechanical system. And that also was an opportunity, as Pierre-Luc mentioned, to improve the remaining labs, or the major lab space, the instrumentation lab for the green chemistry. The challenge, of course, was what to do with the NMR. And so from these photographs, you can see that the NMR and the protection of the NMR and working around the NMR was a particular challenge to the contractor. Ultimately, I can report that the NMR survived construction. However, the restart, I don't believe ever happened, and the equipment was ultimately replaced, not because of the construction, but because, of course, technology and the evolution and the duration meant that they had the opportunity, McGill had the opportunity of purchasing a new instrument altogether. So it's one of those scenarios where, by virtue of an initial request and the challenge of maintaining as much of the lab space, adjacent lab space in operation, but there are ultimate limitations to what you can and cannot do. The other thing that I would say on this is that from a sustainability perspective, this added a little bit of a twist in that all of a sudden our project, which had been an interior renovation, became a complete rebuild. And so it wasn't clear what the most appropriate approach would be from a LEED certification standpoint. And McGill was particularly interested in that because they were in the process of establishing the criteria in terms of assigning LEED certification or green certification goals for each type of project that they were going to have on campus. And so all of a sudden this project fell between two possibilities, and so that was a question that was addressed. But ultimately, as I mentioned previously, because of the nature of the interface and the fact that we are working in multiple zones, the interior construction strategy was the one that was selected as being the most appropriate.
And one interesting fact also about the NMR is because it was meant to be kept there, and because of the magnetic field with all the mechanical equipment, it was decided to put the roof at a higher level of a couple of feet. So we pushed the roof, and so the floor of the mechanical room higher because of the NMR, which in the end was demolished and replaced by a new system that didn't add these requirements. So still.
Lesson learned. So that leads us into sort of our results and observations in terms of looking back on the project. And so we've alluded to it many times, that one of the big challenges of the project was the fact that, contrary to previous renovations that had occurred in Automass over time, where you were looking at renovating sectors or renovating floors. This was one which was basically the lab spaces that were left over and on level 0. And so it really was a piecemeal approach that made the whole process from both the design and the construction perspective much more complicated in terms of implementing it in the most ideal way. Certainly, being able to ensure that the labs, that the adjacent labs were optimal, both in terms of their access, both in terms of the ventilation and the mechanical systems, was an ongoing challenge, both as we were planning it out in terms of the phasing, but also as it was being constructed out. We've already alluded to a little bit about the NMR. I'll let Pierre-Luc speak a little bit about the penthouse.
So here's the result in the new penthouse. As you can see on the back, we convinced the architect to install glazing in the mechanical room. So we had some light there, but also it gave a view from the site to people walking around the building, tried to have a glimpse of what's required to support labs. Instead of hiding all of these elements, the idea was to show partial elements so the people would understand how big is a task to support labs, research lab in these settings. So you have the view in the room with the pumps and everything inside. On the left, you have also in the same mechanical room, and the other side of the room, the other glazing. So the idea was not to put it completely transparent, but to show some of these elements. On the right, you have the existing penthouse on top with the slope ceiling. So these are the heat recovery system in terms of ventilation and the piping. So it's quite tight, but again, I think it's a lot better than it was. And here's a view again of the same mechanical room that you can see the slope on both sides, with all the duct of the exhaust going from all the shafts all around. As you can see in the back, you have multiple ducts going to various shafts in the building that needed to be reconnect and kept operational also during all of the construction. Here's a view from the roof that you can see the exhaust fan compared to the existing element, and you can quite understand how it was open, so it would be integrated and also be less visible from the city and the campus. From the city, which is on this side, it's really not visible at all, and from the other side, from the campus, it's still visible, but it's really, I would say, it's incorporated and it's not as massive as it would be if we just have put it on the roof.
So one of the things that had been asked for in the initial project was this access to vegetation. And so initially the thought had been to perhaps, because of the location of this project as part of a valley, that it was visible from all the buildings around, that incorporating some aspect of a green roof, and initially it had been looked at that this lower portion would be a green roof and that there would be some connection down to the terrace and the main quad area. unfortunately, those are the things that people dream about. But there was always this notion of trying to make the lab, this project, an opportunity to create more livable space. In addition to the fact that one of the other issues that came up is that in the full reconstruction of the mills, which had not been the original plan, there had been a concern about, or sorry, I should say, there was now the opportunity of really improving the building envelope. I mean, before we were looking at trying to sort of adapt with the old stone and the old masonry walls, but we really had an opportunity to improve the building envelope, and of course, navigating both the city as well as the McGill architectural approvals process was a bit of a challenge, but I think everyone is ultimately happy with the result. This just gives you a view at the corner where the NMR was, and now the new equipment has been replaced, and it's just a sense of what we have on the site. You have a view across from one of the plaza areas, and so the building now, in terms of seeing in the valley, it presents a much more favorable view than the initial building. One of the real successes and of the building, I would say, is that in responding to the challenge of how you provide really attractive, livable labs in a basement, we were able to really improve on the quality and the amount and the quality of natural light available in that basement area. And so this is just showing a little bit, this is just showing a touchdown space. It's sort of the common kind of cafeteria meeting space. One of the asks from the users was really to have more of these informal interaction spaces that were really as close as possible to the working areas, to really encourage opportunities for conversations, crosstalk between various researchers as they were going about their day. So that's just another view, and you can see we did really increase the amount of transparency in the lab. So that's one of the main working labs over to the left here. And so that gives you a sense of the workroom and its adjacency to the instrumentation room. The strategy that worked well for us ultimately. So in really building in as much transparency as we could, it really made it so that the lab spaces in the basement that were originally the cast-offs have really become some of the ones that are the most coveted. And again, here a view just directly underneath that skylight. The skylight was a technical challenge. It imposed a number of restrictions and impacts on exiting for some of the upper floors and maneuvering around it. But I think from the perspective of the feedback that we've gotten, it really was a very positive result to improve the livability of the lab areas. And these are just some additional views. Now, previous views were in the pulp and paper section. Now we're over on automass. We were limited in the sense that we were not able to incorporate a skylight to bring in more natural light, but we were able, through the use of transparency, to open up and make the labs feel a little less oppressive than they had before. And this is just the general, a general view of the larger lab area. Again, we used glazing in as much as we possibly could to try and get some of the additional benefits that we'd been able to achieve in the pulp and paper section on the automass side. And then finally, this is the instrument lab, which is in the is underneath penthouse on the mill section. This is a large instrumentation lab. They did need significant height space for some of their setups. They benefited from an abundance of natural light because this was the lab that actually had the most available windows, and they were big, gigantic windows to begin with. And even in the new configuration, we were able to keep most of it. And so that responded well to their needs. And these are just some additional views of some of some of the interiors of labs. So we basically have had to respond to the challenge, and I think we learned lots along the way, I think, in terms of how to navigate certain difficulties with occupied labs more than anything else. But that is our project. So I will leave now with opening it up to questions.
So thank you very much, Deirdre and Pierre-Luc. As Deirdre mentioned, if you have any questions, just type them in and we'll read them out. I do have a question myself. It seems like redistribution of occupants and decanting and stuff like that would have been a huge challenge for such project. Is there any particular strategy that you followed, holding regular meetings or in forms of communication that you did with the occupants, and how regularly this was done? It just seems like this was something that would have required a lot of attention.
Yeah, so what we can say is that in the design phase, one of the things that we have to say first of all is that we had a really good client. It was a client that understood, had been through a number of renovations in the building, and so they understood the challenges of dealing with construction sites. The second thing is that we had the benefit of the whole LEED process came not at the start of the project, but it came in towards the end of concept design. And at that point, we sort of jumped in and we sort of had a series of 3 charrettes. And for the charrettes, we actually had all stakeholders involved. And so we had users, we had McGill staff, and I think that was also helpful in terms of opening up the lines of communication so that they got a clear sense of what, it was a way of addressing what they wanted out of the project, and they had a window into what the project entailed, so that they weren't going in blindly. And then throughout the process, we did have ongoing meetings with our client representative, who was basically at one point he was the lab manager, but he was basically the lab director, and so he was basically on the ground. And the meetings happened once a week with them. So there was an ongoing feedback right through design, construction, and closeout and handover.
Yeah. And maybe if I can add, initially it was also discussed with the client who sell this to their user, that this type of renovation cannot be done without any disruptancy, I would say, or without any effect. So it was quite early that they had this discussion that they would at some point be not that comfortable. They would lose some research capability at some point, and it was quite well understood. There was still some problem during the construction that people were not that happy with the condition, but generally it went quite well because of how the client was able to keep his user and his researcher informed and react to problems, I would say.
And I think that's the key, is just it's really making sure that everyone is informed and it's not glossed over. As Pierre-Luc said, telling them up front, you are going to lose capacity. You're not going to be able to do this for this period of time. I think those conversations are really important.
Well, that's great to hear. Yeah, it sounds like a lot of hand-in-hand kind of, communication, regular communication that was, very important for, through the entire process. So there's a few more questions. A question from Yvonne. How did green chemistry impact the design? What is different between doing a regular chemistry lab and these ones?
Ultimately, I would say, the first part of it was something as simple as the number of fume hoods. But I think ultimately what ended up happening is because the labs got more and more attractive, I think we ended up with more fume hoods than initially planned. But there was the first impact that we had seen as an opportunity was to reduce the number of fume hoods.
Yeah, I would say the research is similar to chemistry lab, but we had some zones that were specialized, like a radio isotope lab, the iBay lab, iSpace, iHead lab that we've shown that was required for a certain type of research. So these type of difference, but in the end, I would say it's really a research lab, but it's mainly focused for the clients and for the user in terms of their what they decide to do there.
Yeah. I think the other thing that is important to note is that we were kind of this is a project that goes back to, I think its inception was in 2013, and so we know that the field of green chemistry has evolved since then. And so I wouldn't be surprised is that if you were doing a green chemistry lab today, because it is a rapidly evolving field, that it will probably look very different today than it did then.
Okay, great. A question from Hamoun. Please summarize on outdoor air requirements, challenges, and design consideration for this project. Yeah, I guess being a lab, obviously, there's going to be a considerable amount of outside air.
Yeah, so I'll take that one, Deirdre, if you don't mind. Well, first we approached that by seeing how many air change rates, what's the air change rate we wanted to have in the lab. We're aiming to around 10 air change, except in the really high lab where we didn't calculate all the height. But also we summarize all the need from in some area it was the heating load that won the calculation, and other area it was the number of humid. So, but the baseline was around 10 air change per hour, and it was the intention to operate at around 8. It's intense research lab, but we felt that around 8 would be okay with the help of the client from the health and safety offices. Mm-hmm. And also one of the big challenges was because of the amount of air and the size of the system and the location of the air intake and the exhaust compared to the adjacent building, which adds, when we've seen the picture of the valley, the high tower on the right that we've seen add air intake on the top, and we wanted to make sure that the exhaust from our system didn't go into the air intake of the adjacent building or re-entrainment because of the valley. So we had a wind study done to try to see what was the biggest element, and in fact it was certainly the emergency generator, electrical generator that you've seen on the picture that was the biggest impact. But still, the way it was designed and decided, it mitigates the re-entrainment of air.
Okay, so we have a couple questions from Lee and a couple questions from Stephen. I believe the ones from Lee are more on the mechanical engineering side. First question is, in some of the drawings, it seems HVAC from mills was distributed to automass, which then distributed to labs. So automass was just served as, a booster fan in quotations from the new HVAC and air intake from the mills.
Yeah, well, I'll give you a point for that one. Pretty good, pretty nice sense of observation. In fact, when we looked at the automass, the system were also obsolete, but there were 3 ventilation systems supplying the small zone that we had in the automass, and to do a dedicated system to the automass, because there are a lot of dedicated system in automass supplying other floor, but there were no capacity left for this zone. So it became evident that we could benefit from the new system in the pulp and paper to supply this portion of automass only. But again, we were able to push air there, but we're not able to exhaust the air through the pulp and paper because of the configuration. So we added another exhaust fan on top of the automass to do the exhaust, but there were already 2 exhaust fans, and we had a third one in parallel, so it gave more capacity to all of the automass tower or portion of the building. Okay.
So second part from Lee, it's related to the heat recovery, and he wrote that he might have just missed a part of this too, but is heat recovery from the stacks from the high plume exhaust fans, or is there some, I guess, presumptively is there some other heat recovery?
Yeah, it's a runaround glycol loop going from the recovery unit just beside the fans, the exhaust fan, and going to the air intake unit into the new mechanical penthouse. So it's a typical runaround glycol loop going between the exhaust and the supply. And also everything is VAV compared to what was there before, which was constant flow. So that gives also some heat energy saving, but that's not different from what you would do in a lab today.
Okay. So a couple more questions from Stephen. So can you talk to us about the schematic design development process, initial budget, and end budget? And this kind of leads into his other question. Final tender cost, also what was the delivery method, stipulated bid or construction management?
Okay. All right. So in terms of the schematic design development process, as I mentioned earlier, the project had gone through, I would say, concept design hand in hand with the researcher looking at, the issues related to delivering the green chemistry labs. At the time when I joined the project, that was really the transition into the schematic design process, and we did a bit of a reset when we started the lead process. So sort of a step back, step forward, and it was a typical sense of going through, looking at requirements that were beyond the sort of square foot areas, and bringing in some of those qualitative requirements, which allowed us to make some decisions in terms of the big moves of introducing those skylights. Because otherwise I don't think we would have gone down that road necessarily. Again, it was charrettes were sort of the anchor point, going from schematic into design development, and then it sort of reverted to ongoing design meetings on a bi-weekly basis. The budget is roughly, and this is where it gets confusing because we had sort of an overall budget, and then we had the lead portion versus the non-lead portion, and also the base building versus the new lab construction. But overall, we're talking about 15 million, and it was a standard design bid build process. So it was a fixed. My brain is working in English and French simultaneously. It was a stipulated bid price.
Okay.
The design bid, typical project.
Great. Well, that's it for questions. If you have any closing comments or anyone has anything else, please shoot it out right away. Although thank you very much, Deirdre and Pierre-Luc. It was very nice hosting your presentation. If anyone has any follow-up questions, would it be okay, Deirdre or Pierre-Luc, to have them email you on the email shown?
Yeah, certainly.
Okay, and just a reminder, this webinar will be uploaded to YouTube as well, if anyone needs to review it. So that being said, we're going to close things out, and thank you very much for everyone attending and for presenting as well.
Thank you to all. Have a good afternoon, everyone.
Thanks.